It is not commonly appreciated that 70% of the cost of a component is committed at the design stage itself. If any cost reduction program has to be comprehensive, the starting point is design itself. We will examine some of the steps in the designing process and see how they contribute to increased cost of the component. The first point we wish to consider is the chemical composition of the material of which the part has to be manufactured. In most of the cases, only mechanical properties of the material for the component are specified. The choice of the actual material composition is left to the designer, or at best, rough guidelines are given about the material. Instead of specifying expensive elements like nickel, boron, tin, etc., the designer should examine if the required mechanical properties can be obtained from a cheaper combination of elements. Second vital step is to design and specify the various sections at different points of the component which will have enough strength to withstand the service requirements of the component. Designers generally tend to specify wall and section thicknesses more than needed, thus increasing the weight of the component, making it more expensive than required. Third point to examine is the surface finish and the tolerances specified at various areas of the component. Smoother the finish specified, higher is the cost of machining. It may not really be necessary to shave off all those extra microns, which will necessarily mean a run at an expensive machining center. Likewise, the tolerances on parallelity, concentricity, and ovality should be doubly examined to prevent over-engineering. Fourth point to examine is the internal soundness specification of a component. Only those components which are in the line of high stress transmission deserve higher specifications of internal soundness. Housings, casings, covers, etc. should be internally sound only to the extent required. Unnecessarily specifying tomography will unduly increase the cost of the component. The fifth point to examine is the prescription of secondary processing on the component, where it may not really be of any useful purpose. Thus 5 and 7 tank painting may not be required, whereas a sealer dip paint may suffice. Or a secondary and tertiary heat treatment may be replaced by a single heat treatment if the essential purpose is served. Or heat treatment may be entirely eliminated by controlling cooling of the component made of suitable microalloyed steels. These are just few examples of how the cost of a component can be shaved even before the manufacturing has started. If this interests you, we can discuss this on 93346 15973 between 10 and 11 in the morning on any working day. Thank you.